I'm Adam Pritchard, and it is pastime for pastime. Bird brain. It's a classic insult, put down, meant to tell someone that they have no idea what they're talking about, that they're just clueless. I myself, shockingly, have been called a bird brain in the past by such good friends as Tommy Dembeck and even my mammal-loving co-host Matthew Bortz. But the reality is, among the living backboned animals, birds are actually pretty smart. Their brains are substantially larger proportionally than those of lizards, crocodiles, and the areas dedicated to reasoning, to trying to understand the world around them, are comparable to a lot of mammal species. But among the birds, no species is thought to be dumber than the dodo bird. I mean, even the name makes you think of this kind of dumb-looking, beach ball-sized and beach ball-shaped mass of gray feathers, this flightless animal that was totally unable to adapt when humans came to its island habitat and hunted them. Dodos lived on the island of Mauritius in the Indian Ocean. That's several hundred miles to the east of Africa and Madagascar. Dodos were first discovered by Dutch sailors visiting the island in the 1500s. Now, the dodo species is actually a giant, flightless example of the pigeon family. That's right, dodos are actually closely related to all of the pigeons you saw walking down the streets if you live in a city. And studies of their relationships revealed that dodos descended from flighted ancestors. Once they arrived on Mauritius, they adapted to the island, which didn't have many big predators. They nested on the ground. They adapted to life-eating seeds. The dodos in nature were probably not as beach balls shaped as the ones we see in paintings. That's probably the result of sailors fattening up the specimens that they took back with them. Unfortunately, once Dutch sailors arrived on the island of Mauritius in the 1500s, they hunted the dodo very extensively. But not only that, they brought invasive species along with them, including pigs, dogs, cats, even monkeys. And these ate the dodo eggs, ate dodos, and outcompeted the dodo for resources. And as a result, less than 100 years after we first encountered the species, the dodo was extinct. On Pastime, we're usually talking about species that have been gone for millions upon millions of years, if not hundreds of millions of years. But in this case, we're not even removed from the dodo by a full 1,000 years. Less than 500 years ago, we could have seen dodos in the wild. But now we have to rely on museum specimens to understand the life of this extinct species. And despite the fact that the sailors killed thousands of them to eat them, there aren't very many left in museum collections around the world. I mean, think about it. Do you hold on to all the chicken bones that you eat? So we have this question. What more can we learn about the dodo? And why did I start this by talking about brains? And the answer to that comes in a new research paper by Dr. Eugenia Gold of Stony Brook University. From the Zoological Journal of the Linnaean Society, the first endocast of the extinct dodo, Raphus cucullatus, and an anatomical comparison amongst close relatives. Now, Dr. Gold, as long as I've known her, has been an expert in the evolution of skulls in archosaurs. This is a group that includes crocs, birds, and their dinosaur relatives, and Eugenia has studied all of them. Her primary research of late has been on the evolution of the brain in the line of dinosaurs that leads to birds. And this research has included such projects as reconstructing the shape of the brains in extinct dinosaurs like tyrannosaurs using their fossil skulls, but also dissections and studies of the brains of modern birds, especially to see major changes in the structural anatomy that may relate to the evolution of that great innovation of birds, flight. But many birds have gone completely flightless, and comparing those to flying birds is a part of this current study. For this study, Dr. Gold and her colleagues took a specimen of a dodo skull on hand at the Natural History Museum of the United Kingdom in London and put that through a micro-CT scanner. This is a miniature version of the CAT scan machines that are present in just about every hospital around the world. And through this, one is able to look inside of an object. And so by doing this, they're able to look inside of the dodo skull. But not only that, using three-dimensional modeling techniques, they were able to build what is called an endocast. An endocast is a model of the empty space inside of the skull where the brain is housed. The brain doesn't always take up all of the space inside of the skull, but by building a cast of the brain case where the brain is housed, one can get a very good idea in some animals, including birds, of the shape of the brain in the living animal. And this dodo endocast was compared to a broad sample of different closely related species of pigeon, some extinct, some living, to understand the major differences between the living species, the extinct species, the flyers, and the flightless. And what they discovered is kind of surprising. The portion of the brain dedicated to smell is relatively large, suggesting that dodos may have relied on that sense more than their modern pigeon relatives. The portion dedicated to sight, the optic lobes, not quite as big, suggesting that dodos may have had a sensory life that was very different from the birds we have today. But comparing the overall size of the brain in the dodo relative to the size of the brain in other pigeons, dodos weren't that stupid. The brains not only remain large in dodos, they didn't really lose a lot of the structures that are present in modern pigeons. I started this episode by talking about bird brains and just how dumb people think the dodo is. But through this research, Dr. Gold has shown that the dodo brain really isn't all that different from those of other pigeon species. And we might not think of them as smart, but pigeons are really successful. And indeed, the dodo was really prevalent and really successful on the island of Mauritius before the arrival of humans. Regardless of how small or large its brain was, it had the tools it needed to survive on that island for thousands and thousands of years. But because of its extinction, the only way we have to understand the evolution and the biology of this animal is with the museum specimens we have today. And now, with advanced imaging techniques and scanning, we have the ability to take a new look inside of the mind of a very successful and very strange species. And that's how this discovery should expand your mind on past times.